Welcome back. Last time we talked about the importance of thinking and how the ability to understand and adapt are important. We'll now turn to some of the classical features of design as it's conceived of in the software development world. This should give you an idea of where the software development process has been and where it's going. I think you'll see that it's heading in a more adaptive direction, and that's a good thing. SDLC stands for Software Development Lifecycle. In general, the SDLC is a set of cradle-to-grave steps through which a software project passes in its lifetime. Back in the early days of computing, in the mid-1950s, when computers switched from using vacuum tubes to using transistors and iron core memory, computer engineers who were participating in organized software writing efforts began to reflect on their experiences. This is a natural characteristic of human thinking, to coalesce individual episodic experiences into semantic structures, meaningful structures, which convey meaning. Herbert Bennington, a computer engineer working on a computer system whose job was to protect the United States against Soviet aircraft and missiles, first describes a step-by-step sequence through which the software passed. This is what we now call the waterfall model. He described 5 steps: requirements, design, implementation, verification, and maintenance. To a degree, these steps are present in all modern forms of the SDLC. Software development traditionally follows a series of phases which together are called the software development lifecycle. The most familiar lifecycle is the waterfall model. One first determines requirements for a piece of software. Traditionally, requirements are considered a statement of the problem to be solved. Technology is injected into the process and a design is produced. The design is the first evidence of a solution to the problem. Implementation is where the design is put into computer code. In the implementation phase, the source code is also converted into files of instructions which a computer can execute. The executing program is checked to see that it performs properly in the verification phase. Once the software is delivered and set up for the users to operate, any actions to correct, adapt, or perfect the software fall into the maintenance phase. The IEEE EIA 12207 standard describes the waterfall model and a number of variations to the model. One of the variations is to fold the waterfall back on itself about halfway. The result is called a V-shaped waterfall. This scheme is linear sequential, just like the original waterfall, but it acknowledges that the phases before coding and implementation phase contain information useful in the various testing phases. In the figure at the right, the unit test phase is closely coupled to the coding phase. The system test phase has its roots in the design phase, and the acceptance test phase is based on the information derived in the requirements phase. One advantage of the V-shaped waterfall is that it clarifies the relationships among phases which can precede coding or implementation, and the phases which follow it. Another variation on the traditional waterfall model is the waterfall with feedback. This model understands that in each subsequent phase, it may be necessary to rework tasks previously done. Thus, in the design phase, it might be necessary to rework some requirements. In the implementation phase, it may be necessary to rework part of the design. This is one way of making the life cycle iterative, where a phase may be executed several times. Feedback can also occur across the entire software development lifecycle. There are 2 lifecycle models which are considered iterative in nature. The first of these is the incremental model. Futrell characterizes this model as having overall requirements phase and an initial design phase, followed by multiple cycles through the remainder of the life cycle. In this figure, each of the 3 iterations begins with a detailed design phase. Although development proceeds in increments, there is a single requirements phase for the entire project. The advantage of this process is that there is some semblance of a product early on, which has a positive effect on team motivation. The fact that each phase is gone through multiple times in the course of product development means there's an opportunity for learning. The second and third times through the design implementation phases allow developers and managers to understand better the implications of the decisions made early on. This feedback tends to make downstream phases more efficient. Unfortunately, the single occurrence of the requirements phase and the lack of feedback arrows to the requirements phase mean that the requirements must be right the first time. Fixing an incorrect or incomplete requirement constitutes a disruption to the process. A final variation on the life cycle is the spiral model. The model is similar to the incremental model, with the exception that there is a delivery to the customer following each verification phase. The disadvantage here is that the customer and the users can see early on what form the software is taking. Subsequent requirements phases leverage customer feedback, and this tends to yield a product more adapted to the user's needs. Additionally, it allows the customers and users more time to understand the impact of the software on their business processes. In this manner, the customer and the users don't have to try to imagine all of the requirements at once. The learning that takes place from iteration to iteration yields better quality requirements. More recently, the concept of extreme programming, XP, has surfaced. In XP, a number of conventional ideas are transformed. For example, one of the tenets of XP is that a customer is working with the developers on a daily basis. This allows continual integration with the customer through the development process. Second, XP is highly iterative. While there are a few once-through planning steps, most of the work is done in short cycles, suggested length of which is 3 weeks. Third, XP is test-driven development. When new functionality is required, a test for that functionality is written. The developer is done when the test and all other existing tests run. Fourth, each programming task is done by 2 people at the same time. In pair programming, one person is the tactician, the person with the keyboard, the mouse, and the ideas on how to satisfy a particular test. The other person is the strategist, looking at what the tactician is doing, but against a larger backdrop. The strategist may see a better way to resolve a problem, a way to unify several specific problem solutions into a more general case. In XP, a lot of design is done by refactoring. Refactoring is reorganizing and rewriting existing code so that it is more efficient in the context of new code. Although the XP model is quite different, the familiar ideas of requirements, design, are simply hidden. They're not absent. Requirements are most clearly represented in terms of the tests. There may be thousands of automated tests that are run to verify the functionality of the software being developed. XP wisdom is that a feature without a test is not a feature. In more familiar terms, if there's not a test, it's not a requirement. Design is accomplished through refactoring. To be sure, there is a broad design concept in place when the project is begun, but an XP design is not predetermined. Rather, it evolves over the course of development. Provisions for pervasive requirements exist as well. They're often called stress tests. The evolutionary prototyping lifecycle model, however, gives very short shrift to formal requirements. In the evolutionary prototyping, the prototype intentionally becomes the delivered software. According to McConnell, with evolutionary prototyping, you start by designing and implementing the most prominent parts of the program in a prototype, and then adding to and refining the prototype until you're done. The prototype becomes the software that you eventually release. As the concept is simple, so is the diagram. Requirements in this system would appear as bug reports or modification requests for the prototype. If there is a clear and defined process by which the prototype is evaluated and upgraded, then a reasonable list of requirements is available at the end of the production process. Under the title of Dynamic Systems Development Method, evolutionary prototyping has been turned into a process in which requirements are explicitly called out. In the diagram here, the explanation of functional model iteration is, quote, selecting requirements according to their priority and performing detailed analysis and modeling of the selected requirements through prototyping, unquote. The requirements are more apparent, being referred to explicitly, than in the early version shown in the previous figure. Dynamic Systems Development Method. Let's take a look at Agile software development. Agile is an iterative process where each iteration has common features, such as requirements analysis, design, and test. This diagram shows these iterations as separate from one another. A different way of looking at the cyclical Agile process has been proposed by Alistair Coburn, who is a noted writer and practitioner of Agile. His representation is a set of nested cycles. The outer level is the entire project. It proceeds from beginning to end, clockwise from the 12 o'clock position in the diagram. The circle inside the project circle is the delivery cycle. The idea is that multiple deliveries per project, and that's one of the fundamental characteristics of Agile. Inside the delivery circle is the iteration circle, so there can be multiple iterations per delivery. The next circle is the day circle, which means that an iteration is composed of a set of days during which a similar set of steps is followed. Scrum practitioners are familiar with the morning stand-up and the subsequent activities throughout each day. Inside the day circle is the integration circle, meaning that ideally there are multiple integrations of the software per day. Of course, this implies a lot of automation. And most notable, inside the iteration circle is the design, code, and test process. Far from the original notion of a waterfall design step that may take months or years, we have a design process that goes on from minute to minute, hour to hour, and is probably unique to each developer. In each of these models, it's important to identify where the requirements are, how they're constructed. The table shows where the requirements are located in software development lifecycle models that we've discussed. The important point to be made here is that simply that regardless of the lifecycle, software developers must deal with requirements in some form. Okay, this was a long lesson. We've talked about where design sits in various software development life cycles. There are two major points to be made. First is that design is present in every software development life cycle. Second, as the software development life cycle becomes more adaptive, design happens in shorter and shorter cycles. In the next lesson, we'll talk more specifically about what happens in the design phase in these various life cycles. Thank you.